I am Mrs. M. Jyoti, Assistant Professor, Department of Physics, Sakti College of Arts and Science for Women, Ottanjatram. Torsion oscillation of a body. Suppose a wire is clamped vertically at one end and the other end carries a body. The length of the wire is small l and the radius of the wire is small a, and the rigidity modulus of the wire is capital G, and the moment of inertia of the wire is capital I. When the body is giving a slight rotation by applying a torque, the wire is twisted. If the body is released, the body oscillations in the horizontal plane about the wire. These oscillations are called torsion oscillation, and this arrangement is known as torsion pendulum. Let us consider the energy of vibrating system. The potential energy of the wire is half into c theta squared, where theta is angle of twist and omega is the angular velocity of the body. Kinetic energy of the body is half into I omega squared. Already we know omega is equal to d theta by dt, so that value is substitute half into I into d theta by dt the whole squared. The total energy of the system is kinetic energy plus potential energy. These values is substituted half into I into d theta by dt the whole square plus half into c theta the square, that is equal to a constant. Now differentiating this with respect to t, half into I into 2 into d theta by dt into d square theta by dt square plus half into c into 2 theta into d theta by dt is equal to 0. So the common values are cancelled. I into d square theta by dt square plus c theta equal to 0. That is also d square theta by dt square plus c by I into theta equal to 0. Suppose the body is oscillating in a simple harmonic motion. The period of oscillation is t is equal to 2 pi root of I by c. That formula is used to calculate the period of oscillation. Now the rigidity modulus by torsion pendulum. Let us consider a torsion pendulum consists of a wire with one end is fixed in split junk and the other end is center of circular disc. Two equal symmetrical masses are placed along a diameter of the disc at equal distances d1 and the either side of the center of the disc. The disc is rotated through the angle and then released. The system executes torsion oscillation about the axis of the wire. The period of oscillation T1 is determined. T1 is equal to 2 pi root of I1 by C. T1 squared is equal to 4 pi squared by C into I1. Here I1 means moment of inertia of the whole system about the axis of the wire, and C is the torque per unit twist, and I0 is the moment of inertia of the disc about the axis of the wire, and small I is the moment of inertia of each mass about the parallel axis passing through the center of gravity. Then parallel axis theorem, I1 is equal to I0 plus 2I into 2m into d1 squared. Whereas T1 squared, period of oscillation for T1 squared is equal to 4 pi squared by C into I1 value is substituted. Now the two masses are now kept at equal distances D2, suppose, the center of disc, and the corresponding period of oscillation is T2 is determined. Now T2 squared is equal to, similarly for T1 squared, so T2 squared is equal to 4 pi squared by C I0 plus 2I plus 2m into D2 squared. So these two period of oscillation is subtracted. T2 squared minus T1 squared is equal to 4 pi squared by C into 2m into D2 squared minus D1 squared. Now the C value, C is equal to pi into capital G A power 4 by 2L. That value is substituted in the equation. We calculate capital G. Capital G is equal to 16 pi Lm into D2 squared minus D1 squared by A power 4 into D2 squared minus T1 squared. Using this relation, we can calculate capital G. And Moment of inertia of the disc by torsion oscillation. The two equal masses is removed and the period T0 is found when the disc along the vibration T0 squared is equal to 4 pi squared by C into I0, or I0 is equal to C into T0 squared by 4 pi squared. C is equal to 4 pi squared 2m into d2 squared minus d1 squared by t2 squared minus t1 squared. That value C is substituted in that equation I0, or I0 is equal to 4 pi squared 2m into d2 squared minus d1 squared by t2 squared minus t1 squared into t0 squared by 4 pi squared. Then 4 pi squared is cancelled. 2m into d2 squared minus d1 squared into t0 squared by t2 squared minus t1 squared. That is the final value for moment of inertia. That moment of inertia is calculated for torsion pendulum. Thank you.